Right. Good morning to everybody. So today we're going to discuss mainly the email and kind of cloud security. So if I remind you what we did so far, uh, we start with the introduction and then we discuss about how this cryptography used on the case of cybersecurity, and we discuss major protocol which use in the web, one of the main application on the cyberspace. When you consider the cyberspace, we can see several applications. World Wide Web or the internet is one of that. And in this application, web application, so there is a protocol called TLS. So we discuss how this TLS works, and then how the what are the weaknesses of those TLS protocols, and so and so. And then on top of this TLS, the people are running what we call it as web application. So in the last lecture, what we discussed was these web application security and what kind of weaknesses which might occur in those while we are writing web applications and so on. And how do we analyze those web applications and so on. So today, so there are two things left to discuss in this course. One is the other protocols which executed on top of this internet. The other one is basically the kind of network security part. So I thought of finish these other application, that is email. So for example, when you check cybersecurity, in addition to the web applications, emails are the kind of popular application which works on the cyberspace. And obviously, most of those applications, we store the data on the servers or the cloud services. So we discussed today this security of email, and then kind of how cloud service providers cloud problems with this cloud storage and so on in very abstract level. So I will start the discussion with the email because email are kind of most popular application over the cyberspace. So before I go into the email, I just want to see whether kind of a popular myth what I feel, and then unpopular reality on the cybersecurity. Myth is basically people think if there are firewalls are there and TLS is there, of course TLS always the same, both are the same. And then if viruses scanners are there, then everything is get protected. Uh, as I mentioned several times, we considered our information, which these information are on move. When the information are at rest, so they are in high risk on the cyberspace, but we neglect that. So I feel that is the unpopular reality. Unpopular reality is in the cybersecurity world, basically we completely forget about why is the information at rest. So especially email. Emails are the systems, basically which do store and transfer. So always emails store on somewhere on the cyberspace. So most of the time when the email get transferred, it may be protected, but as storage, it's not. So we will see how the email works. So this is the best definition I found long time ago about the email. Perhaps in your countries also there are systems, what we call it as postcards. In addition to the letters, people can send open postcards. So if you write a message on the postcard, everybody can see that. And if you write a message using a pencil on that whole postcard, someone can erase and write something else. So basically, the best definition for the email is actually we can define the email as a postcard written in pencil. What that means? That means anyone can see the message, anyone can alter it, And obviously, anyone can send a postcard as anyone else. So then, with the regular email systems, since anyone can see this message, there are no confidentiality. Since it's written in postcard, as I mentioned, anyone can write and delete and write another message. There are no integrity. So you can write a postcard like I am posting it. So then there are no authenticity. So that's how email is. That's how emails are. And that's how email basically works. So uh, how do you improve that security? Basically, there are two standard protocols available to improve email security or they provide the security for email communication. So these protocols are what first one is called PGP, Pretty Good Privacy. Other one is called SMIME, Secure MIME. SMIME is a standard, international standard, which propose to secure email communication. PGP is kind of an industry people or the personal users. Personally, people use the PGP to protect their email communication. PGP can use by anybody at any time as they wish. But if you want to use it SMIME, there are several other conditions, especially what we say, we need to have X509 public key certificates, similar to the web. In the web, in the internet, if you want to have TLS, the web servers, we have to purchase public key certificates. So similarly, if we want to use SMIME, we have to purchase public key certificate. Individuals has to purchase. That is kind of not practical, and people are not doing that. And other thing is, these days, we are using online email services, not the kind of offline clients. So we store our email on online servers like Gmail, Yahoo, and we connect to those servers through the web. So that's how we have access this email. Online mail servers or the mail service providers, they are not supporting any of these two standards because they are looking for information. They want to look at our information. Why? They take our data for marketing purposes. So, for example, you might notice, so in Gmail or Yahoo, it doesn't matter, any online provider. So when you use such online email providers, so when you write a message, and if, let's say there is a message in your inbox, so most of the time, advertisements comes to your web browser is relate to the message in your inbox. That proves those online service providers are reading your content. They are not manual reading, but they use tools to analyze the content and get the content and personalize the advertisements to your email content. That means actually they are reading your mail. So in case they implement these two standards, they may not be able to read your mail. So then they cannot do marketing. Then they cannot make revenue. So because of that, they never ever implement these two standards. They may not implement it even in the future. These online mail service providers definitely not support these two standards. However, if you want to use these two standards, there are ways to use it using different tools and different third-party methods. Let's start our discussion in using SMIME. So in the internet, so when you have the mail, there is a standard called multi-party MIME extension or MIME content. So any documents usually created on the net using this MIME standard. So MIME standard defines set of headers and the body. Most of the time, the body consists of multiple parts. Multi-part internet mail exchange. That is actually MIME refers to. So each MIME message, as you may see here, has different sections separated by what we call it as labels. So this is the MIME header. So these are the content. This content consists of different sections, parts. When you define a MIME header, we can tell it is which kind of document they are. Usually on the web, it is HTML. So maybe some emails, maybe it is multi-part, maybe it's an image, maybe it's a video, maybe it's a text. Like there are different content types. So that's how we define the MIME. So this particular MIME standard extended into a security standard called as SMIME, Secure Multi-Part Mail Extension, or Secure Multi-Part or SMIME, what we call it as actually SMIME. SMIME follows another standard called PKCS standards. PKCS refers to Public Key Cryptography Standard. This Public Key Cryptography Standard has several standard numbers starting from 1 to 15. PKCS number 7 discusses a data structure to store the data in protected form. Actually, MIME or SMIME, so SMIME messages built on top of this PKCS 7 data structures. And let's have a look how these PKCS 7 data structures look like. So in this data structure, there are several fields, as you may see: version, signature algorithms, content information, public key certificate information, certificate revocation list, and the signer information. So in the PKCS 7 has two data structures, what we call it as signed data structure and envelope data structure. Right now we are looking for signed data structure. In the signed data structure, so major section is the sign information part. In the sign information part has sub attributes. Their version, sign ID, who is going to sign this message. Digest algorithm is when creating the signatures I mentioned, first of all, we create a hash and we encrypt this hash using the private key. So this hashing algorithm is actually called as digest algorithm. And then authenticated attributes means time of signing and some other attributes. And digest encryption algorithm means actually public key algorithm. So whether we're going to use RSA or elliptic curve like cryptography algorithm to sign it. So we have to tell what algorithm we use. Otherwise, verifier may not know how to verify that. Finally, the signature, encrypted hash, usually called as signature. So this consists of the signer information. So content information is our content, MIME content. In case of email, this is our email content. Then content type is text or maybe HTML. So what we do, we put our content into this content data structure and we get a hash of it and we encrypt this hash using the private key and put that here and tells about which hashing algorithm used, when we sign it, and which encryption public key algorithm we use. And all put it into a sign information field and create a data structure called signed data structure. Similarly, PKCS 7 standard discusses about a different data structure called envelope data structure. This envelope data structure used to provide the confidentiality. So as you know, when you want to encrypt the content using the public key encryption, if our content is too large, the time for this encryption becomes kind of huge. Practically, we cannot use we cannot use public key algorithm directly to encrypt the bulk data. So there what we use is a symmetric key algorithm to encrypt the data. So then I discuss, we have a problem. How do you going to send this symmetric key to the recipient? So the same problems occurs when you try to apply these standards or the algorithms into the email. So PKCS7 analog data structure provide the way to do it in a better method. So there, again, they provide a data structure for that. So the major section of this data structure is a recipient information field. So this recipient information field has some sub-attributes, what we call it as version number, recipient ID, key encryption algorithm, and encrypted key. What is that? So basically, in this PKCS7 analog data structure, what's happened when it creates, first it creates a symmetric key. So such as AES or the DES algorithm they use. So using this symmetric key cryptography, they use a symmetric key. They create a symmetric key. So that particular symmetric key will be encrypted to this recipient. So if you have a recipient X, we should send this message. We have to get the public key of this recipient X. So then we generate a session key, symmetric key. So that session key or the symmetric key encrypted using this public key. So then we tell about which algorithm we use in this field. So for example, if you use RSA, so this consists of the public key of the recipient, ID of the public key, and then this says about RSA, and this consists of the encrypted session key or the encrypted symmetric key. All together that called as recipient information field. Then obviously we have the content. Content we need to encrypt. That's what we're going to do. So content is our email content or any other content. So this content actually encrypted using this key created here, session key. This content is encrypted with this session key. And then we should mention which type of algorithm we use to encrypt that, whether it is AES or whether it is DES. And then we tell us about type of this content, whether this content is an image or a text or HTML or whatever, we tell us about the content type. Then encrypted content information data structure or the field consists of the content type, encryption algorithm, that is always a symmetric key algorithm, and then encrypted content. So this content is encrypted using a symmetric key, as you understood. So then that key, where we include that key is in this field. So we included that key by encrypting that key with the public key of this, our recipient. Lest this recipient receive this data structure, then he has to access the content. So in order to access the content, he has to decrypt it. In order to decrypt it, he needs to have a session key of this algorithm. So how do you obtain that session key? That is included here. So then the recipient should get his private key. Private key is stored at the recipient end with the custody of recipient. So recipient using his private key, decrypt that field that he get the session key. So that session key he used to decrypt this content and he can get access to the mail. So that's how this analog data structure works. So as you may see in the previous data structure, it provides the signature, and this data structure, it provides the encryption. So when you discuss about the security services behind them, signature provide integrity, authenticity, and non-repudiation security services. So encryption provide confidential security services. So if you only use this data structure, we only have the confidentiality. So because signatures are not there. If we use previous data structure, we have integrity, authenticity, and non-repudiation, but we don't have confidentiality. But in the real life scenario, we need to get confidentiality, integrity, authenticity, non-repudiation, all of those security services. How do we achieve that? So if you want to achieve that, we need to apply these two data structure one after other. So for example, first of all, we need to create this signed data structure, digitally signed message. Then we take this entire message as the content of this and encrypt it. So first we have the signed message. On top of that, we enveloped it or we encrypt it. We call it as enveloping because we are not directly encrypting it. We do encrypting using symmetric key. We then encrypt the symmetric key using the public key. This is kind of hybrid encryption. So that's we call it as the process of envelopes. So this one call it as a process of signing. So usually, practically what we do signing and then we envelope. As you may understood, so most of the email protocol works based on text. So after create this PKCS7 data structure, it is in binary. So we have to convert the binary data to the text. So that in order to do this conversion, we use encoding algorithms. Some people get confused with encoding and encryption. Encoding transfer data in one format to other format or other whatever other ASCII range or binary to text or whatever. So there is a different encoding algorithms available. So email heavily used encoding technique, what we call it as base64. Base64 encoding convert any binary data into a text range. So then entire binary can be represented as a text characters. So obviously, when we do this conversion, size of the text is larger than binary data. And in this example shows how it look like this when you convert this PKCS envelope data into a final email message. So you know it has a header. It encoded with base64, and it uses the file type or the format called SMIME PKCS7 M. This is envelope data. Similarly, we can use signing. So when you sign the email messages, we use a method what we call clear sign. Because most of us, when you sign emails, let's say I'm creating a signed emails, maybe my recipient may not have the support to decode and interpret this signature or verify this signature. Because my recipient may not have sometimes application which support SMIME. Then he may not get access to my content. So because of that, in case we only need to provide the integrity, not the confidentiality, if integrity and authentication purpose, we could use clear sign formats. There we have one section of the MIME to include our data, other section of the MIME to include our signature. So this is then how the signature look like in the email. So this is signature of what? This message. So like that, using this SMIME standard, we can create encrypted messages that call it as envelope data. We can create signed messages. So we can create signed and encrypted messages. And we can create clear signed messages. So in different formats. So all these process required public keys. So SMIME uses X509 public key certificates similar to the public key certificate used by TLS. In order to configure the TLS, we have to issue the public key certificate to the web service. Similarly, if you want to use SMIME, we have to issue the public key certificates to the end users. So because SMIME used by the people, like you and me, end users, not the web service. So in order to do that, we need to obtain public key certificates from the certification authorities. Or else you can use the scripts which I provided, simple scripts like that, and create public key certificates to yourself. And you can configure those certificates in your email clients. It is not online email clients because online email systems are not supporting SMIME. So if you want to use SMIME, there are third-party plugins, and you have to use third-party email software, offline email software. So one drawbacks or one kind of barrier to use SMIME is basically these public key certificates, because people has to purchase those public key certificates from the CA servers, or people have to run their own CAs and issue the public key certificates to their end users. That is kind of a hazard. And this is an example of such SMIME email provider, which I think it's called Edora, it's a long time ago. Even now Thunderbird and Microsoft email readers may support this SMIME. So most of these email clients, they might have a tab called security tab. In the security tab, there are options, you see, digital design, encrypt, and so on. So you can use those options to protect your content. So if you use online emails, so those features are not there. Right. So let's have a look now, the PGP. So PGP stands for Pretty Good Privacy. So that's created actually before the World Wide Web, somewhere in 80s. So PGP is considered as first kind of cryptographic protocols in the world. So in order to use PGP, we don't need to have X509 public key certificates. Anyone can use PGP to protect their email content. Maybe some of you are already using PGP. Some of you are not aware of how to use those PGP. Let's have a look how PGP works and how do you practically use PGP. PGP again provides same security features such as authentication, confidentiality, and they have additional kind of compressed messages and so on. Mainly these two. Let's have a look how PGP message structure. PGP do signing and encryption in one single data structure. So in order to understand how do you create a PGP message, we could use this diagram. So here in this tells about the content. On this side describes the operations which applies to this content. So you see here, so we have the data that is our email and time of signing and maybe a name if it is attachment, file name and so on. So this is actually our email or our document, PGP document content. So what we're going to do for this content first is we're going to digitally sign this content. So for that, what we should do first, we have to calculate the hash of that content. So hash, also call it as message digest. We have to create a message digest of this content. Right? So this is message digest. That is hash of this content. Right? Then we do our first operation here. That is, encryption this hash using our private key. Encryption hash using private key in this context is a signature. So we mentioned that if you want to sign a message, we are not directly encrypting the message with the private key. Instead of, we calculate the hash of this message and encrypt that using the private key, that is called as a digital signature. So we create a digital signature. So then we put some other attributes related to the signature. All together, from here to there, we call it as the signature of this message. So we have a message, we create the signature of this message. So this is the first operation. So in the next operation, we have to encrypt this entire content. So entire content again here encrypted using a session key. So system has to create a session key. This KS is that session key. So before do this encryption, what we do, we create the session key and we encrypt that session key using the public key of the recipient. Because recipient has to decrypt that. Recipient, we need to pass that session key to the recipient. So how do we pass it? We encrypt that particular session key using the public key of the recipient. So, and tells who are our recipients here. So when the recipients get this message, then he could use his private key to decrypt that header and get access to the session key. So this session key will be used to encrypt this entire content. Right. So this is signing, this is encrypting the session key. So after that, you see there is an operation called zip, compression. Why do you need compression? When you apply security to any data structure, usually the size of the content increase. So we would like to keep the size same. So the method we have to do that, method we should do for keep the content same size is compression. So someone might ask, why do you compress it here? Maybe after we apply all the security operations, perhaps we can compress it at the end. So that is the other important factor theoretical factor you have to remember. So when you do some encrypted content, create encrypted content equally distribute the data throughout the ciphertext. So how do you compress the message? So basically, when you want to compress the data, so in these compression algorithm works or like to see the redundancy of the patterns. So in compression algorithms, what happens? They identify the redundancy of the data and use those redundancy patterns to reduce the size. So compressions use patterns to get good compression rates. Encryption algorithms usually removes these patterns. Because of that, when you compress the encrypted content, we may not get good compression rates. So if you want to get a good compression rate, you have to compress plain text data. So then after compress, we could do encryption. So not the other way around. So that's why you see here there is an operation called compression. Entire data structure they compress. So then after compress it, they do encryption, this data with key KS which generated here. So they encrypt the data. So then entire this data get protected. So then this data is in the binary format. We have to convert into the text in order to transmit via the email protocols. This conversion happens with the base 64 kind of encoding algorithm. So that if I summarize the process, we create the signature, we create the session key and encrypt that session key to the recipient. Then we compress the data structure, we encrypt the content using the session key, and then we encode the entire data set. So that completes the PGP data structure. So that PGP data can transfer to our recipient. So how do the recipient access that? Recipient first of all has to decode it, then he gets the encrypted data, then he has to decrypt that. In order to decrypt that, he needs to get access to KS. So KS is included in the header. So the recipient should use his private key to decrypt that session key and get the KS. Using the KS, he do the decryption, and then he do the uncompression or the decompress, and then he get the signature and the message. Then recipient has to verify the signature. So that complete the access of this PGP. So that's how PGP works. Right. So in the PGP use again public-private key, as you may see, but they are not using public key infrastructure, or what you call it at X509 public key certificates. They are not using that. Instead of, they use their own format to store those public keys. So that's what we call it as public key rings. They do have two rings. One is their private key ring, which consists of the private key used by a particular user, and they have public key ring that are the public keys of their friends. When as a user want to put a public key to a public key ring, so first of all, user has to put that public key into the ring and digitally sign it. So then its public key ring is somewhat similar to the set of certificates signed by you or the end user. So end user works as a certification authority, kind of. So each user who use PGP has to maintain these two key rings. Public key rings signed by himself or herself, that is the public key of his or her friends, and the private key of you. So this particular model, we usually call it as web of trust, because there are no hierarchical ZAs or no type CA infrastructure there. We have the web of trust because public keys of your friends may included in your public key ring as well as some other users' public key rings. So there are no structured method of handling those public keys. So it's up to end users. End users somehow obtain the public key of their recipients and write that public key into their public key ring. After that, they could use those public keys to create PGP messages. So that is what we call web of trust. So then we can define as you, it's all the public keys kind of relate to you. You could store those public key and you say this is trusted by me, this is halfly trusted, and so and so. So based on the PGP program, they provide different ways of handling those public key rings. In case you want to use PGP, so there is a free software available. So that call it as GNU PGP or GPG. GNU PGP, it's a kind of recursive definition. PGP or GPG, it's called GNU PGP. GPG in the name. So if you use any Linux or the Ubuntu variation, you can use apt-get install to install GNU PGP, like that. And after you install this, first step you have to do is generate the private public key for you. I'll show you that in a minute. Then you can list those keys, and in this generate public private key will generate two keys for you, public key and the private key. The private key, it's called it as sacred key. It's keep only with you. So, but public key you have to send to your friends. So then your friends can send the encrypted messages to you. So for that you have to export your public key to a file. So this command will export it to a file. Then this is my public key then, for example. So this public key I can distribute among my friends. So then if my friend receives this public key, he has to import that public key to his key ring, public key ring. For that, this is the command. After he import that, he has to tell this public key is trusted by himself. For that, so this is the command. He digitally signed the public key of me, my friend, digitally signed and put it into his trusted public key ring. So after that, using this command, he can create a sign an encrypted message to me. So, and then he, after create, he could send this message to me. So then I receive this message. So how do I then view that? So if I want to view the message, I just run GPG and that file name. So it processes that and can give me the message, the encrypted message. So then I receive that perfectly and I can read that. So that's how GPG works. Let me show in brief how it works. So then you can try yourself. Okay, I will share, I'll open a terminal and share it to you. Give me a minute to do that. I share my terminal. So you see in that terminal, I have some files here. This is my email message, assume. This is a message. It's a some text message. Maybe any message, doesn't matter. Or any image or whatever. So actually I have created my own keys already. So if I want to list those keys, I can use this command to list them. You see it has the key created here and it also has the key created on that day. The two keys already. How do you create that? You can run this command to creating the keys like this. So it has your name, email address, and so and so. Maybe I will create some name, let's say Khalzun. It asks the email. Maybe I use some other email. I have two emails here. I use maybe some other mail address like that. And it asks to confirm it. Okay. And then it creates the keys. And it requests the password to protect that key. So it say my password is weak, anyway I say go ahead. Right, it created public private key pair for me for this particular email. So when I execute now these list keys, you see now I have three key pairs for three different email addresses. Right. So then I want to get some confidential message from you. First of all, I have to export my public key. So how do you do that? I have to run that. I say GPG export -a and give which key I want to export. Let's say I want to export the key which I just created. Like that, I give my email and then I can run that. It shows the key on the terminal. So this is my public key. So I have to send it to you, so then I have to save it. I have to redirect it to a file. So let's say this is public key of puzzle. So it is now created, a public key here, fine. So then that public key I have to distribute to you through the key server or directly email it to you or maybe using a USB drive or however format. So it's not defined. So I need to use trusted method of distributing this public key to you. So you get this file. So you get this my public key file. Then after you get this file, you have to import that file into your public key ring. For that, there is a command called import. This say GPG import and this key. So you see it's imported. So after it imported, you have to tell the system I will trust that key. So for that, you need to run this command. Say I trust that key. This key. Right. So then that public key accepted by your PGP software as trusted key. So it asks the password to sign it, it signs. So now it's ended up in your trusted public key ring. So now you can, using that key, now you can create, sign an encrypted message to me using this command. Sorry. So you have to say encrypt, sign, -r, and you tell to whom you're going to sign and encrypt. So you have to tell my email like that. And which file you want to sign. So this is the message file in my directory. So I think I have a file in the directory. Let me see. So this is like that. And this is the file I'm going to sign. So when you check that, there is a message for message.gpg. That is the encrypt digitally signed and encrypted message. So that you can send it to me. After I receive that message, I have to execute on my side and then the file name. So actually I am doing it myself, so I have already message file, that's why it asks whether overwrite it. If I say no and write it to a different file, let's say plain, so it then create a different file consists of this message. This you see. So when I see that, it is the message basically sent by you to me. That's how we can sign encrypted any document, any message into the PGP format. So as you see, it requires pre-setup, that is the keys. So that need to be done manually in between you and me, and it's not going through a certification method. Right. So as you know, most of you are using online email systems such as Gmail, Yahoo, and so and so. So you are using, if you use such email system, how do you digitally sign those emails? So as I mentioned, online email service providers such as Google, they are not supporting it. So if you want to sign this Gmail, for example, you have to use third-party plugins. So there are such third-party plugins available. I will show you one of these plugins, very nice plugin, which we can use to digitally sign emails. So let me use my Chrome browser and share it. Let's share. Okay, I share a desktop so you see everything. So this is, see my Chrome browser. So in this browser, I have installed this plugin already. So this is the plugin, Mail Analog. So we can kind of see that plugin. So there are, different security settings available. You can, using that plugin, actually you can do encrypt, decrypt your emails. So there are buttons to encrypt, decrypt, you see, and then there is a button for key management. Under key management sections, you see, I have one valid key here. So those keys store in my local browser, right? First time when you install this Mail Analog plugin, you have to use this generate key button and generate a key for you. So like, I can say like that. And you need to type your correct email address. Let's say I have an email address called like that. This plugin support Yahoo and Gmail, so like that. So then you type password, and you can upload your key to a key server. You can say no, like that, and you can generate a key. So it's key generation in process. Right? You see now I have two different key pairs. This is my default key pair which I use for Yahoo. Gmail. This is a key which I use for Gmail and Yahoo. So these public-private keys store on this particular browser. So if you, in case you want to get signed and encrypted mails, you have to give your public key to your recipients. That is again here manual. So for that, you need to export your public key. So if you give it to your friends, don't export all or private keys, because then your private key will go to your recipient. That should not be done. So you have to export public key. You select your public key and then you say export and save it to a file, right? It is saved somewhere, you see. So that public key you can send to your friend. So your friend then import it to his browser. His browser should have this same plugin. So you can import using this import button. You can copy and paste this file. You open it and copy and paste the public key of this file. This is a text file. Maybe you can open it in a text editor and copy and paste here and import that. So like that, you have to pre-set up your keys of you and your friends. So then this plugin is ready to use. So then you can go to a particular online mail client. For example, this is my Gmail. And you can compose a new mail. When you compose a new mail, you see this mail envelope plugin is there. You can write that or place that button, or you can just type your, I'm writing to myself to show that because I don't have anyone else public in my plugin. So let's say this is secure mail, and you can say hello, whatever. So you can press this button. Or you see this messages appear here. Or you can press this button and write the message here. So if you have corresponding public key with you, it can give you to encrypt the message. So it's actually sign and encrypt. So there are options. You can say if you only want to encrypt that, you can pick to whom you're going to encrypt and whom you're going to sign and so on. So if you want to sign it, you say sign using this key and then encrypt it, right? So I am actually writing to myself. Then it asks the password to access my private key. Oh, sorry, I forget that password. Let me try again. This time I think I am okay. Right. Let's create the PGP message. You see, it's a PGP message. Let's create that data structure which explains and encode it and put it like that in your mail. And then you can say send it. So you see, since I wrote to myself, it appears on my mailbox. So when I open it, it shows that it's a PGP message. So then you have to click that mail envelope plugin button to see the message, access the message. So in order to access that, it asks the password of my private key. So you see it's decrypted and show the message, and also it's a digitally signed by this person. So it's protected, right? So even Gmail cannot read because Gmail's only see, let's remove that, Gmail only see this. So when you access that, actually on top of that, they show the PGP window, and then you click that, it asks the password to access the private key and access the private key and decrypt and show the message. So then I can view that particular message only using this particular browser. So for example, let me use this browser to access that, log into this mail. I use my private mail address, that is Kazun Dizoida address. So I go to that, this one. Sorry guys. I go, let's go to this browser, and then I go to this, right? This is my Safari browser, right? You see this mail is there. So this Safari browser, it don't have this plugin installed. So you see these messages look like that. No one can read. Even the Gmail cannot access to that. It's protected. It reads. So when I go to this, my Chrome browser, which has this mail envelope plugin installed here, so then I can read that. So then you see, when I go to that, then I can read it after typing my private key password. So this browser cannot read. So you see there are plus and minus points. So the advantage is you can protect your mail. So it is not a postcard written in pencil anymore. It's protected. It's digital design. It's encrypted. And you can confirm that it's a digital design encrypted. So you know it's sent by the correct user and no one alter it and no one see it. It's confirmed if you use this plugin. Right? Even Gmail cannot see that because you see here, Gmail see only this, right? So the negative side is, so only you can access that message using this particular browser, which has your keys. If you want to access it, this browser, you have to export your private keys from that browser and import into this browser. That is kind of a manual process, and you see it's not practical doing it every browser and so on. So the best way is you having one browser which using those plugin install and the keys with that. So all the confidential communication, you can use that. So let's say someone has executed man in the middle attack and taken your Gmail keys, Gmail password. So then he might log into your Gmail to see your content, but he may not see the content because he see this. Someone else log into your Gmail account using your keys, a password, so they might see this. So they cannot access this content. First, they may not know the key password and they may not have your private key in their machine. So this private key is only in your machine. So then if someone wants to get access to your email, they have to physically get access to your machine. Then they have to know your password to access your private key. Obviously, they have to know your password to access to a Gmail. So there are several barriers to get access to this content. So unless otherwise you don't use this PGP or S/MIME, actually S/MIME is not supported. So fortunately there are PGP plugins available for online mail systems. Unless otherwise, you are communicating with postcards written in pencil. So obviously these online mail service providers can read it. Someone else, you have access to your keys, password of Gmail or whatever can read it. And somebody at the middle, like web proxy servers, which I show you in the last session, can read it and so on. So if you don't want to see that, use PGP or S/MIME. So I already described or explains how to do that. When you consider the email, this integrity, authenticity, confidentiality, and non-repudiation could achieve using PGP and S/MIME, email has quite a lot of other problems. So one major problem it has is, spams. So perhaps most of over 90% of the emails in the world are spams. What kind of spams we get? So many types. Advertisement, charity appeals, financial scams, chain letters, phishing letters, malware spreads, so many kind of spams we get. Advertisements, emails are heavily used. So charity appeals are, they are asking different things like tells about some stories and and say if you forward this to 7 people, God bless you or something like that. So then what you do, you forward to maybe not 7, maybe 14 to get more place. So don't do that. So they are spams, unwanted mails. They waste your resources, such as bandwidth, time, and so on. So other types are financial scams. So most of these financial scams, call it as Nigerian scams, because most of them are from Nigeria. Most of those emails originate from Nigerians. So those financial scams, what they do, they tell us about you won a lottery or something else and so on. And then they kind of try to get out some of your money in small amounts. So if you're interested, you can follow those financial scams. Usually you ended up with two ends. So let's say you won a gold jewelry. So then if you follow it up, at one point they might tell, so this is too expensive. So in case to post this gift to you, you have to take online insurance. So then they may give a link to take insurance. So then you go to this site and insure your gift which you won accidentally. So, and paying some small amount, maybe $1, $2 insurance fee. That's it. You may never receive that gift. So those bogus insurance companies are controlled by those bad guys. Similarly, some of these, if let's say you won a cash prize, so if you won a cash prize, usually that story ended up with the online bank site. So this bad guy may ask or send you a link saying, so we cannot transfer this to your home country. So because of that, you have to create an online account. So then you might create an online account. And then this online account website or this online bank website is a bogus website. So then there is an account opening fee there. So that's it. So you may not get this financial gift. So the bad guys will collect small account opening fees. So similarly, there are so many methods and so many types of spam. Among them, I'll discuss a little bit of phishing in a minute. So in order to do these spams, so the spammers has to know your email addresses. How do they get it? They get it from different posts, different mailing lists, maybe from your web pages, or maybe from companies. So for example, if you register for any web server or any service, they are asking your email address. So you are typing in your email address. So those companies are collecting your email address. So later on, those companies might sell those information to the advertisers. So most of those companies are actually doing it. So like that, you might expose your email address to those spammers. So in some of your personal home pages, you are like to expose your email address so then new people, friends can contact you. So perhaps you know there are some software I already showed you in the last week like Harvester. So using that, people can collect your email addresses, automatically collect those email addresses. So we are not advising you to publish those email addresses. So then, how do you publish them? So the best method of publishing your email address is basically using an image. So if you want to post your email address, create an image of that and then post it. So then automatic robots or email retrieving softwares may not detect that. Otherwise, if you just publish it as text, people may take it and start sending you the spams. How do you then stop spams? There are techniques. Among them, the oldest technique is blacklisting and whitelisting. So this blacklisting may never work today. Why? Spammers may never ever use same email address to spam. So they might use one email address today, and if you blacklist it, that may not work because in the next day they are using different email address. So in the whitelisting is opposite of it. So then you can maintain a list of email addresses you accept in mails. So that works, but there is a problem. As you may understood, if some new person want to reach you and his email is not in your whitelist, he cannot reach you. So there are some solutions provided to those whitelisting. So there are two-step email systems available, online servers, and some softwares available. So with these softwares, what they do, so they let you to maintain the whitelist. If someone write an email which is not in your whitelist, this software automatically generate mail to that person. That mail tells you are using this whitelisting software, and in case you want to reach this particular person, write him back with some code. So then your new recipient has to rewrite that email back. So as you know, these most widely spammers use tools. Using those tools, they send millions of spams. So among them, maybe 200, 300,000 mails get bounced back. So if someone uses that whitelisting, that also get bounced back. So these tools may never ever check whether that why they get bounced back and so and so. If it is not a tool, if it is a human, and when that mail get bounced back, human may write it again. So then if that person write it again, that will reach to you. So that's how this simple whitelisting tools works. In addition to that, there are so many methods called integrity check, reverse DNS lookups, and rule-based filtering. Most of these mail servers, basically they use rule-based filtering or the AI techniques and reverse DNS lookups to identify spams. So they using the text in the mails and also images, links, though these AI filters basically most of them are not rule-based now, they are basically AI filters. They know, identify, they can identify whether that mail was spam to some extent. So, you know, most of these online mail system, they have a spam folder. So behind that, they are executing those filters. So when they receive an email to your mailbox, so they execute those filtering engines, and if they identify this as spam, that they put it into your spam folder. So that's how they tackle the spams. As I mentioned, one of these dangerous kind of spam is phishing. The phishing, what people do is try to collect confidential information by sending emails. So what kind of things they try to collect? Maybe username, passwords, birth date, credit card numbers, or any other confidential information using phishing mails. So what are the phishing techniques? Most of the phishers use link manipulation and spoof website, or what we call it as look-like websites. Look-like websites, people can create look-like websites in minutes, or actually seconds. There are tools available. So using the tools, for example, let's say Facebook, you can give you a website you want to forge or duplicate. So you type, let's say, facebook.com on these tools. So then that tool will automatically create Facebook look-like website. So only the front page actually. Because if it is a website, all the content is public. So they could retrieve those content, image, links, text there, and save it. So then when you open it in a browser, it's similar, like Facebook, for example. So then what these phishers do, so they purchase the bogus domain, look like bogus domains. So maybe instead of facebook.com, they might purchase facebook.info. There are so many thousands of domain names, top level domain names. So they can purchase some of these domains and host that duplicate site in a particular domain. And then they send you a mail saying, here I have uploaded nice photos to the Facebook, click that and have a look. And they might say Facebook, and the link they put behind that is not Facebook, it's a bogus website. When you click that, you are at the bogus website, or what you call it as look-like website. So its appearance is similar to the Facebook, but when you carefully look at the domain name, it's definitely different. But most of the end users may not realize that. They see only they only check the appearance. And then they might type their usernames and password there. Then in the look-like website, the attackers, they basically create the backend code to record this username and password and automatically redirect you to a real Facebook, for example. So, and then in a minute, you are at the real website. In a second, actually, you are at the real website. You may not notice you were attacked by some fisher. So like that, there are so many other phishing techniques. Using that, they will create phishing mails and collect your confidential data, especially username and the password. So because of that, we say never ever click the links on the emails. But you know, we are so addicted to clicking the links. Whenever we see the link, we click that. So for example, if you want to visit some website, we usually tell us, please type the website URL and log in, go there, rather clicking the script link. Because when you click the link, there might be scripts behind which executes, like the confidential data. You might go to a different look-like website and so and so. There might be so many bad things can be happen. So this is some example of phishing mails. So when you want to try such phishing mails, and when you want to check whether your organization, employers in your organization are aware of this phishing, there are some phishing framework available. So the one called it as GetGoPhish. So you can try yourself. So usually, so using this framework, some people executed what they call it as phishing test on the employers to make sure whether the employers of your organization are aware of these phishing. So using those tools, you can create the bogus phishing mails in seconds and send those phishing mails to your employers and see whether how many of them respond to, or how many of them submit their credentials to those your phishing mails. And then you can show those dangers of that to their employers, and then ask them to change their password and so on, educate them properly before real fisher hit your network. Right? So you can try that yourself if you're interested. And in the email security, other dangerous side is attachment, you know. So most of the malware use attachment to spread. So fortunately, most online mail systems, they have virus scanners integrated. So when they receive the emails with attachment, they automatically scan the attachment against viruses. So because of that, the spreading malware via the emails now get reduced. Instead of now, most of the malware spread by USB drives or kind of other memory cards and so on. So usually we tell, so when you have attachment on a mail, don't open that. But some email systems, they automatically executes those scripts or the attachments. So if those consist of malware, then your system get infected. The other important thing which I would like to mention when I discuss those emails, so for example, if you write a mail to a group of people, so you are using, so I still see most of the people are using a CC field. You know, in the email system, there are three fields. What we call two CC, that refers to carbon copy, and BCC, that refers to blind carbon copy. When you write to a group of people, some people use carbon copy field, CC field. So if you use CC field, everybody in this communication thread see each other's email address. So if you really want to show that you can use CCC, unless otherwise don't use CC field. Instead, use BCC field, or what you call it as blind carbon copy field. When you use blind carbon copy or BCC field to spread a message, so then no one else will see each other's mail addresses. That is very important. Why? Let's say you use CC and send a mail to a group, and one of these recipients is infected with a malware. So then this machine will receive a mail, your mail, with a list. So then what this malware will do, they retrieve all the mail addresses from your mail and spread themselves to those new users. So that helps the spammers that helps the malware to spread. So you expose quite a lot of new email address to this malware by sending these CC mails. So you put all the people in that CC list on risk. We never know one of these recipients is infected. Who knows that? We never know. So if you only use BCC field, then one of these recipients is infected. Only you are on risk. You are on risk because recipient only sees from you. Recipient may never see the rest of the people you send this mail. So don't put all the people on risk. So in case you want to send a message or event invitation or something like that, just use blind carbon copy field instead of carbon copy field. So that is a good practice when you're writing emails. That kind of, I can conclude the email part and would like to discuss a little bit of cloud. Because nowadays, all the data we are storing on the cloud. Cloud are the kind of servers on the cyberspace. So most of the time they are VMs. So we can get different other cloud services and so on. So you interact with those services and store your content there. So in case you are storing confidential content on those cloud service providers, you need to be very careful because we never know where those data get stored. Some of the countries which hosting these cloud service providers may not have proper legal frameworks to support the your data protection. Some of these countries may not have privacy laws. So those then cloud service providers may take advantage of those to steal your personal information or to get your data. Because when you upload the data, so this data can access by the service provider, so without any problem. Obviously, when you access the clouds, you might use SSH or VPN or TLS. So then your data in transit is protected because from your machine to the cloud, it goes perfectly protected. But when the data address, that means your data is stored on the cloud, they are in plain text. So Someone else take your password, can access the cloud and take it, or in by default cloud service provider can take it. So obviously you might tell those service provider may never take that. Who knows? Who knows? Maybe some government intelligence agencies, maybe some people who wants to kind of analyze this data may take your content. So what is the solution for that? So simple solutions someone might tell. So we can encrypt and store on the cloud. Obviously, you can do so. For that, you can use tools like PGP or other tools, encryption tools like OpenSSL. And then before you uploading your content to the cloud service providers, you can encrypt your content locally using your keys and upload to those service providers. So then when you want to access them, first of all, you have to download this encrypted data to the local machine. Then you have to decrypt and access that. Obviously, you can do that, but that creates some practical problems. Because if you, let's say you are hosting a cloud service database and you store your data on this database, obviously cloud service providers can access data in your database. So then you might decide to encrypt that and upload to the database. So when you encrypt it and upload to this cloud database, then obviously no one can process this data because it's encrypted. The corresponding key which required for decryption is with you in your machine. Then if you want to access this data, you have to download, decrypt and access it. Then if someone wants to process it, which is storing on the cloud service provider, they cannot process it because they cannot access this data. It is in encrypted format. And also there are problems of key management and so and so. So encrypting and storing the data on the cloud, it's not practical. So that even though we know how service providers, cloud service providers will see that data, we don't have any other option, rather we storing it in this plain text mode onto the cloud. However, people are thinking about new methods of doing it. One of the methods people are discussing about it, called it homomorphic encryption. Somewhere around 2008 to till, people still discussing homomorphic encryption. There are some partial homomorphic encryption algorithms are available practically, but still there were no practical implementation which I can see on this homomorphic encryption. But this idea is very interesting, and there might be theoretical mathematical algorithms available where we have to search. So RSA, for example, is considered as partially homomorphic encryption algorithm. But people are searching for fully homomorphic encryption. Let's try to understand conceptually in very abstract level what homomorphic encryption is concerned. So for example, let's say you are implement an IoT system where some device collect some temperature or some values and store them in the cloud service provider. So usually what we do, your device will read that and upload to the service providers. So if this data you read is confidential, what you have to do is you have to encrypt that data to some other value and upload this encrypted data to the server, like that. So then the server consists of the encrypted content. Obviously then cloud service provider may not see that. So let's say these values, you want to add them together or multiply them together. So these values in your application runs on the server, browser. That you cannot do because this is encrypted data. So in regular encryption algorithms, when you encrypt the data, it's a different numbers. So if you cannot add them, there are different values. So if you store the encrypted data, only option you have is you have to download them, decrypt them, add them, and encrypt back and upload them again. That is not really a good way to do that. So in the homomorphic encryption says, if we use homomorphic encryption methods to encrypt this data, so we can prove we could process this data here at the server without decrypting. So that's what we call the homomorphic encryption. So we do homomorphic encryption algorithm to encrypt that data, and we upload this encrypted data to the server. So still this data is in encrypted form, we can then process that. For example, if you want to multiply them together, we can multiply ciphertext or the encrypted data together and we get the result on the server. Right? So then when you want to get them back, you can download the processed data and then decrypt and get the results. So that result is similar to processing the plain text. So these homomorphic encryption algorithms are designed in such a way. If you use regular encryption algorithms like AES or RSA, you encrypt the data and upload to the server, you cannot process here, because if you process this, you get some result, and that result decrypt, you may never get the same result here. So if you use homomorphic encryption to encrypt your data and upload to the server, you can process this encrypted data and keep that results also in the encrypted form in the servers. So whenever you want to access them, you download them and decrypt and access. So that is convenient. So there are some algorithms are available. So that's called as homomorphic encryption algorithms. Unless otherwise you use such homomorphic encryption algorithms, the data which store here, it's not protected. So that you have to know. Then at the end of this lecture, I would like to discuss about some other things, few other things. So you know, long time ago, if you want to run some server, so that is a separate machine. So database is one machine. Your OS is another machine, whatever your application run on the other machine, web service is other machine. So they are physically separated machines. But later on, you know, there was a concept, what we call it as, some concept, what we call it as virtualization. In the virtualization, we have one operating system, there are several virtual machines runs. So there is one hardware, on top of that, there are several virtual machines runs. So it's look like that. There is one physical hardware. So on that physical hardware, virtualization software runs. So virtualization software virtualize it to a different operating systems. We call it as VMs, or the virtual machines. So this, on top of this OSV runs our application. So each virtual machine kind of isolated. So usually cloud service providers give us such VMs. So, however, those VMs run on top of the same hardware on top of what we call virtualization environment or VM layer. So if this one instance get infected with malware, so it's very rare that can spread to the other VM, because it should go through this virtualization server, and most of these virtualization servers are properly tested and with very, very kind of minimum chance with those, this malware can spread between VMs. So because of that, we say those are nicely isolated instances. But nowadays, we are moving further down in this concept, which we call it as containerization. In this containerization, we are running what we call it as containers. Containers consist of our application and the minimum binary libraries which we require to run this application. And in the containerized concept, we are running those containers on top of the same host, same operating system with shared libraries. So if you compare these two together, so that's look like this. We have hardware, host OS, the virtualization software that's called hypervisor, and on top of that, we have VMs running. So we virtualize the hardware, and on top of virtual hardware, it runs the guest OS and then application. So if application runs on the guest OS and VM to the hypervisor and the host OS, and then talk to the hardware. You see, it's a very heavy, because two different noise always runs on top of that. If you different VMs run on the same hardware, many OSs runs and many virtual OSs run. But in the security point of view, they are nicely isolated. But in the execution point of view, they are slow, require a lot of resources. That's why people move from this model to this model, what we call containerization. In this containerization nowadays, we have hardware and host kernel with kind of virtualization, and then we run what we call it as containers with our application. Containers may not consist of different operating systems actually. If some applications we require some OSs but linked to application. So it basically talk to the same OS on the down. Because of that, it's low cost, efficient, and so on. But in the security point of view, we are sharing the OS. Here, independent OS. But here, containers kind of sharing those. Because of that, there is a chance if some malware infected here can spread through those OS to the other containers. So now you know most of the open source projects, softwares are bundled as containers because it's very convenient. So we just need to download this container and run that. So all the configurations are predefined and done. Everything is preset it up. So in the execution time, in the deployment point of view, containers are very, very good solution. So you know there are some container software. So the same thing I explained to you, host, and the container in the VMs there are different guest OS runs, but in the container one OS runs, and all the containers share. So all the now cloud service providers support those containers. So famous containerization technology called Dockers. You know there are server called Docker Hub. People can put those Docker containers there, and then other people can fetch those containers and run on any of those cloud service providers and so on. So when we do so, we never ever think whether those containers consist of malware. Plus, if we run two containers on the same guest OS like that, if that OS has a malware, then we don't know what it happens. So because of that, security in Dockers or the containers getting really complicated. So they don't properly isolate like VMs. So because of that, we need to think about new models, new method of securing those containers. Because in the cyberspace, instead of now, in the cyberspace, we see a lot of containers running. So what's happened now? We have a hardware level. On top of the hardware, we are running VMs. Inside the VMs, we are running containers. So like too many abstractions. So each abstract layers. So how do you handle the security? It's kind of really complicated. So people are still working on that. So we never know still a proper method of handling those things. But practically we are using that. Most of now, the cyberspace, cyber applications works like Docker containers. So people put those containers and runs that by assuming these containers consist of clean codes. That is not always the good assumption. So then what might happen is we never know. So with that thought, I would like to conclude the lecture today. So there we discuss documents, clouds, containers, and so on, the new technologies which use on the cyberspace, and give you a feeling what are the tools available to protect yourself, and give you a feeling still some areas there are no proper methods and tools available. So we have to use them with risk. With that, I can conclude the lecture and open then for question and answer sessions and discuss that, the questions if you have any. So there was a question asked saying, does PGP keys minimize the vulnerabilities for email encryption? Actually, PGPs provide the confidentiality, integrity, and confidentiality of emails. If that code or email, inside the email, if it is a phishing attack, or if inside the email if there is a malware, so the PGP doesn't source that. So for example, I can send a PGP message which consists of malware to you. You will decrypt that. You get the malware. PGP doesn't stop that. What PGP stops is the content is encrypted, so no one will see that. So that provide only the confidentiality. It may not remove the vulnerabilities inside this email. Okay, so there's only one question. Maybe other people have questions they can ask, type those questions. I can answer that since we have a little more time. And as you may aware, already our organizers announced that there is an exam. And then our last session is scheduled on next Saturday evening. That's where I discuss the network security in brief. Okay, there is another question on, is security in Gmail guaranteed? Because when we type, I have attached a file, I don't attach a file, system inform about attaching a file, and also these days suggestions and so on. So of course, Gmail provided the malware, stop malware infections and things like that. So that is correct, but the content is visible to the service provider. Gmail service provider plus any other which intercept your communication. So Gmail not provide confidentiality, integrity, and authenticity for your content. It provides these features while your email in transit. That is Gmail, you connect to your Gmail server through TLS, so no one can take it at the middle if you use TLS, unless otherwise someone is a good man in the middle attack. However, so when they store them in the Gmail servers, it is plain. So some government agencies, Gmail company itself will have a look on that. So that's the problem which I discussed. And then there is a question, is Docker container suitable for separate OS installation? So Docker containers can have separate OS, but still kind of part of the OS. Like for example, if there are Linux Docker containers, Windows minimum Docker containers available, those containers, when you run on top of Docker engines, so they share some binaries of these host OS. So that is the problem. So if host OS is compromised, so all the containers can get compromised. Or if one container gets compromised, so that malware may try to spread to the other through the host OS because they are not isolated properly like VMs. But running the software, deploying the software using a Docker is very easy. So very convenient comparing to the VM. So because of that, people use Dockers heavily without completely forgetting about the security part of it. So then there was a question from Niranjan, shall we encrypt message using Chrome or Firefox browser? You can, this MailAirLog plugin which I showed you support Chrome, Firefox, and few other browsers. So, and few online mail servers such as Gmail, Yahoo, and so on, you can use. You can use those browsers and then those online mail servers with those plugins to send protected mails. The problem is with those I mentioned, so you can access your mails only using this instance of this browser. So you cannot, for example, if you use your laptop to send those mails, you can read those only using that laptop. So if you want to access mails from some other machine, you can't. That's the disadvantage. But if you have confidential data, you should use such encryption. And then there is a question: is Docker container method is useful for DNSAD server installing running? Obviously, most of these applications, not on the DNSAD, so all the open source application, they now provide Dockers. They provide Dockers. So because if you use other VMs, you have to download this software and then configure it. With the Docker, you'll download the Docker image and just run it. So with zero configuration, like minimum configurations. So because of that, everybody use Dockers, and all the softwares, open source softwares, now spread or now distribute as Docker containers. So in that angle, that is very nice tool, but in the security point of angle, still not stable. So that's why I want to mention to you. Right, then there was a question, will the mail tracking software consider as security threat? Mail tracking software, that's depend. So for example, there are mail tracking softwares. So using those mail tracking softwares, we could see who you are communicated with whom, and so and so. So if you do some kind of works for some agency which handle, maybe organization which handle confidential information, so then it's kind of a threat, because then people can understand who you are and which groups you communicate with, and so and so. So it's depend where you work. And then there was a question asking, in my opinion, site encryption, trust, third party or manual encryption are always securing data, but all of them have issues, difficulties. Is there any technology approach like distributed computing, blockchain can ensure this data security? No. So my simple answer is no. So in this question mentioned about distributed computing like blockchain, so people think blockchain will protect all security things in the future. So it's a myth. If you store your information on blockchain, you don't have any confidential. It's a distributed and store everywhere. It's not provide the confidential. Actually, blockchain try to achieve some other security requirement, that is integrity. So we call it as immutable properties. With the blockchain, we could achieve the immutability of your information, or the what we call integrity. That means no one will be able to alter this content. Hard to alter the content. But the confidentiality property is not achieved using blockchain. So obviously there are tools and some software suggesting they could do that encryption on the blockchain and so on. So still not mature. So as you mentioned, Rashid, so if you use encryption, decryption, sometimes it's not practical and so on. So that's why you have to decide the level of confidentiality of your content. So if you have confidential content, you have to then kind of sacrifice your something, kind of practicality, sacrifice some resource to do encryption and decryption, things like that. If your data is not so confidential, then you can just go ahead as it is. So that's depend on your application. So if you try to do this protection for each and every piece of information, so that may create a lot of overhead. So then there is a question, is Docker container is payable, Windows AD, or open source? That depends. So for example, if you get a Windows Docker container, that is you have to pay because you are running OS. Windows AD, for example, it's payable. You have to pay and get those containers. So not only open source software, also commercial software vendors also now use Dockers to distribute their software because it's easy. There are no installation, no configuration, minimum configuration. So for some Docker containers, you have to pay. For some containers, it's a free. So for example, if you use any open source software and they have Docker containers created on top of open source, then it's free. If it is a commercial software and then they create Docker containers with that commercial software, then you have to pay. Right? I think I have answered most of the questions. So today, which last questions I got, even though I have kind of like around 50 participants, 48 participants. So that's maybe you understand what I teach today properly, or maybe you already know about those things before. Right. If you don't have any other questions, maybe we can close the session today. So organizers, maybe over to you. Hello?
Yes, sir.
We can close the session, right? There are no questions and things like that. We will have
if no any question from the participants, then we can close our today's class, because already it is 12:55. Time is over almost.
Okay, then okay, there's another question. Maybe I answer this last question from Nazim. Difference between PGP versus public-private key cryptography. What is the difference between PGP versus public key private key cryptography? That is actually a good question. PGP is the application. Application of public key cryptography. So, which in the beginning I briefly introduced public-private key cryptography and the symmetric key cryptography, and then later on what I discuss is all the protocols which I discussed is actually the application of those cryptography. So for example, TLS, digital public key cryptography and symmetric key cryptography. For encryption of the communication, right? So data in transit. So I repeat, data in transit protected by TLS, which uses public key cryptography. So the which I discussed today is data at rest. So like emails, which is stored on the servers. So when you use PGP and encrypt the data, so this data get protected at rest. Since it encrypted, of course, it protected in transit as well. So when you use PGP for email, it protect while that data in transit plus while it is at rest both. So in the PGP is application of public key cryptography. Right. With that, maybe we close the session today, right? Thank you very much for all of you participating in it. And we will have our last session on Saturday.
Yes, sir.
Okay?
Yes, 10th August, Saturday,
right.
At 3 p.m. in Dhaka time.
Right.
Yes, sir.
Okay, then. Bye for now.
Okay, sir. Thank you very much.
Bye.
Okay, sir.